Hi folks, so today what we're going to be doing is we're going to be learning a little bit about triangles, okay? First of all, triangles guys are plane figures, very much like squares and polygons. They are essentially enclosed figures, okay, that are made up of three sides, okay? There's many different types of triangles and we'll get into those in a while. But first of all, we'll just basically learn about triangle parts and angles. Also as well guys, triangles, they are very useful in construction. You'll often see them used in bridges and buildings, okay, because what they do is they offer supports, okay. So eventually in time when you're doing possibly your CBAs, you might look into triangles and how they can actually help us in construction. Okay, but first of all what we're going to start off with is triangle parts. Okay, so we see here in front of us, I have just drawn in a basic triangle, and what we're going to do is we're going to learn about some of the parts of that triangle. Starting off with guys, this here, the line here at the bottom, that is always called the base line. Okay, so I'm going to write that in there. That is the base, B-A-S-E, line. Okay, and that is up to there. Now, if you have the base line, okay, on the bottom, inside in here, you also have what's known as the base angles. Okay, the base angles are just on the base line. So this in here is the base angle. Alright, I'm going to write that in there as well. Actually write it in over here. Base angle. Base angle there. And once again over here, base angle. Okay. So far we have the base line, we have the base angle, okay, and the next parts we actually have are these things called vertex, okay, and on each triangle is made up of three sides, three angles, okay, and each side then will meet at a point, and each point is called a vertex, okay, so this point right here, okay, just make a little mark on that there, little mark on this one here, so this one is called a vertex, V-E-R-T-E-X. This one, the exact same, vertex. And then the top one, it is a vertex, but generally the one we call at the top, we actually call it the apex, okay? So that one right up there, very important, is called the apex. Okay, so far we have a baseline, we've got base angles, we have vertex, we've got apex. And now, often when we associate with triangles and what we actually call the height of it, okay, from the baseline up to the apex, that will be what is known as the altitude. Okay, so I'm going to write that in out here. So I'm going to do a line out here like this, and a line from the top out, like that, and then a line here, like this, and two little arrows, and writing in sideways there, I'm going to write in altitude. Another way you could also do altitude is from the baseline up here like that as well. Okay, there is our altitude there as well. Once again, I'll write that in. Okay, so there's just some of the triangle parts that we're going to be learning about. Okay, baseline, base angles, the vertex, okay, the apex at the top is very, very important. Okay, that's a word, our word we actually come across it quite a lot in graphics. And then the altitude is in relation to the height from the baseline up to the apex. Okay, now just take you down here guys, and we'll go on to a little bit on angles. And when you're associating triangles with angles, we know that the sum of all the angles within a triangle, okay, which there's three angles, okay, as we can see up here, here and here, the sum of those three angles adds up to 180 degrees. Now sometimes as well when we talk about triangles, we have these angles inside in here, okay? The angles inside of a triangle, okay, are called interior angles, okay, or internal angles. So that angle there will be known as an interior angle. So I'm going to write that in here. Interior angle. And sometimes it can be known as an internal angle. That is the interior angle. Now, I'm just going to use a little different color here. I'm going to use a green. If that's the interior angle, like the interior of a house, okay, this angle out here, I'll do it like this. Okay, if that's the interior, this one is the exterior. So that's the exterior angle there. Okay? And often when we're drawing triangles, whatever this is here, let's say that was 40 millimeters. Well, we know the sum of an angle on a straight line is 180. Therefore, we can work out, if this one is 40, we can work out what this one is by subtracting 40 from 180, which would mean that this is actually 140, okay? So, interior angles, exterior angles, okay? Inside here, you have an interior angle. If I was to extend this line here, I would have an exterior angle, and so forth, okay? Or actually, it would be along here, apologies, okay? And the exact same here, if I was to extend this line out, I'd have an interior angle and an exterior angle. Okay. Now the next part, guys, we're going to go on to is just some little bits on different triangles. Now, the very first one we're going to learn about is this one up here called an equilateral triangle. Okay. An equilateral triangle is a triangle that has 3 sides of the same length and 3 angles of the same length. So, we know the sum of 3 angles inside a triangle adds up to 180 degrees. If we were to divide that by 3, every angle would add up to 60 degrees. So I'm going to start off by drawing a triangle in there. Move that out of the way. And I'm going to pick a line here anywhere. This is my baseline. Doesn't matter. And what I'm going to do, I haven't got a length in it. But what I'm going to do is I'm going to use my 60 degree set square. I'm going to do a line up. I'll actually do it in construction first, nice and light. So 60 degrees up like this. And then 60 degrees up here, like this. You can see there now. I'll be able to work out where they're going to meet. So just heavy in that now. It's up to about there, I'd say. Happy with that. And then finish it off this way. So there is our equilateral triangle, okay? Where every side is the same length, okay? So that length, and that length, okay? From here to here is the same as from here to here, and the same as from here to here, okay? And all of the angles are the exact same as well, okay? All the angles are the exact same. So those 3 angles in there are all 60 degrees. 60, 60, and 60. Okay? So all sides same length, all angles same. So we'll write that in. All sides same, and then all angles same. Okay, so all sides same length, all angles same length. 60 degrees, 60 degrees, 60 degrees. Now, an isosceles is slightly different in where that two sides are the same length and 2 angles are the same length. So in this case, I'm actually going to just do a very quick one down here. I'm going to do a baseline, kind of like that, a little bit slimmer, okay? And what I'm actually going to do is I'm going to use my protractor. And I'm going to set it up at a 70 degree angle. So at this point right here, I'm going to put my protractor on it. Right at the end of the line, I'm going to read up 70. So there's 70 there. And I'll do the exact same at this point here, at the end of the line here. So from there, 70 degrees I should say, sorry. So having used that, 70 degrees and 70 degrees, I am now going to draw up 2 construction lines, and hopefully they'll meet somewhere close to the top. Yeah, happy with that. And there we go. There is my isosceles triangle. An isosceles triangle, as I said, is where 2 sides have the same length and 2 angles are the same degrees. So we can see that the angles down here, okay, that I just did with the protractor, that one there is 70, and this one here is 70. Okay, that means if 70 and 70 adds up to 140, the angle left up here at the top would actually be 40. Okay, and we can also see that the length of this side is the same as the length of this side, whereas the one at the bottom is the shortest. So we've only got 2 of them that are the same. Okay, so in that case, 2 sides same, and then 2 angles same. Okay, so you can see this one. 3 sides or all sides are the same and all angles are the same, and in this one it's 2 sides and 2 angles. Okay, So that's the difference between an equilateral and an isosceles. Now we're moving on to a scalene. Okay, so in a scalene triangle, what you actually have is no side is the same length, no angle is the same length. So it doesn't matter how you draw a scalene. I'm just going to start off once again with a straight line. Okay, I'll keep it quite low actually. Something like that. I don't know what angle I'm drawing this at. This is just a random angle. I'm going to go up here, maybe something like this, and then down here like this. Don't know what angle they are. Doesn't matter. Okay. If I was to measure that with my protractor, I can probably work it out. I'll just see what this one is. This one is telling me that it is 60, 70, about 70, 71.5. Okay. This one over here is, reading the other way, is 48.5. Okay. And then obviously we'll be able to work out that. So a scalene, no angles are the same, no sides are the same length. Every one of these sides is different length, okay? So in this one, no sides, same, no angles, same. Okay? So none of the sides and none of the angles are the same. Now, the next one we have is a right angle triangle. And a right angle triangle is exactly like the one I have here, literally on my board, okay? Where one of the angles is going to be at 90 degrees, okay? If I was to show you up my other set square, this one is also a right angle triangle, where one of the angles within the triangle is at 90 degrees. So you can see this is a 30-60 triangle, okay? Because one angle is 30, one angle is 60. And this is my 45 degree set square, where one angle is 45, the other is 45, and then obviously we have 90 as well, okay? So, in that case, what I'm going to draw in here, guys, is a right angled triangle. Now, it doesn't matter, okay? I'm going to do a line straight up, vertical, and a line straight out, horizontal. Doesn't matter how far, because all that matters is that one angle in here is right angled. Okay, and we can see that usually is identified by a line like that, okay? That means it is right angled by that little symbol in there. So we have a right angle triangle in there. Don't know what this angle is, don't know what this angle is, doesn't matter, this is still a right angle triangle, okay? So one angle is at 90 degrees. One angle, 90 degrees, okay? Now, the other thing to note on a right angle triangle is that the longest side, okay, is called the hypotenuse, okay? So this side here, we can see that is the one that has the longest side. It's usually opposite the right angle. That there, guys, is called the hypotenuse, okay? Something you would often learn about in maths, okay? So just write that in there. That's important to note. That there, that line there will be known as the hypotenuse. Okay. Now, the final one, guys, or the final two, I should say, is where we have an acute angles triangle, okay? And acute angles, sorry there. So, the final one, guys, is what we have here known as an acute angles triangle, okay? I'm just going to move it down there slightly, okay, so we can get a bit more space in there. Right, folks, so the last one we have here is an acute angle triangle, okay? An acute angle triangle is essentially a triangle where none of the angles inside the triangle, so the interior angles, okay, add up to 90 degrees or greater. Every one of them is less than 90. So in this case, guys, you can actually see up here, a scalene one would technically be an acute angle triangle. However, this time I'm going to draw one that where the line is not horizontal, okay? So I'm going to start off by drawing one that's not horizontal. So I'm going to put it in here as best I can, something like this, okay, and come up to about, I'll actually extend that just a touch further, to about there, and there we go, okay. In that case there, guys, we have an acute angle triangle where all the angles inside here are less than 90, okay. So just using your symbols, I have to recheck my symbols there, okay, but all the angles inside here are less than 90, so less than 90, less than 90, and less than 90. Every angle inside there is less than 90. All angles less than 90. Okay, so there we go, guys. That is an acute angled triangle. Now finally, the very last one is an obtuse angle triangle, and this is where one of the angles within the triangle is greater than 90 but less than 180, obviously. Okay, so if I was to draw that in as best I can there, kind of freehand, something like that. I'll keep it a little bit skew as well, something like that. Okay, so that triangle that I've drawn in there, now we can see in this case that this one is actually greater than 90. So greater than 90. This one is less than 90. And this one is also less than 90 up here. Okay, so less than 90, greater than 90. So in the obtuse triangle, we know that one angle is greater than 90 degrees. Okay, that's just a little bit there, guys, on triangles, okay, at the very start of the chapter. So we can see here triangle parts. You need to know these. We have the baseline, we have the base angles down here and down here. Okay, these are the base angles here and here. Okay, we've also got vertexes, vertices I should say. So this is a vertex, this is a vertex. That is where you have the points of the triangles. Up here is technically a vertex, but the top one is always called the apex. And then the height, okay, otherwise known as the altitude, is from the baseline up to the apex, okay? And that can be either a line in here, or you could actually bring it out from the outside, okay? Finally then, we also have angles, where we have the interior angle, which is the angles within a triangle, and the exterior angle, which is the angle outside of a triangle, okay, on a straight line. And then we have the various different types of triangles. Equilateral, all the angles and all the sides are the same. Isosceles, where two sides are the same and two angles are the same. A scalene, where no sides are the same, no angles are the same. A right angle triangle, where one angle is 90 degrees. We can see that down here, little symbol down there, okay? And then obviously opposite the 90 degrees is the hypotenuse, which is the longest side. And then we have an acute angle triangle, okay, where all the angles in the interior of the triangle are less than 90. And then we have an obtuse triangle, where one angle is greater than 90 degrees, okay? That is just a little bit on triangles there, guys. I hope you found that helpful. The next day we will go on to constructing triangles. Okay.